7 mountains stood on this exact ridge just 6 years ago. 7 solid peaks that had existed for 100 million years. And today, in that exact same place, there's a runway, 2,600 meters of flat concrete sitting where those mountains used to be. And if you walk to the very end of that runway and look down, you are not looking at a taxiway or a service road. You are looking straight over the edge of a cliff, 1,200 meters down into one of the deepest gorges on Earth. And that is not an accident of geography. That is the entire design, because engineers in China decided the only way to connect one of the most isolated, most beautiful, and most inaccessible regions in the country to the rest of the world was to erase 7 mountains completely and build an airport directly on top of where they used to stand. And what you are about to see is exactly how they did it. Blast by blast, cave by cave, mountain by mountain, until nothing remained but a runway floating impossibly on the edge of a gorge. Before this airport existed, reaching this region from the nearest connected city meant a 5-hour drive along narrow, winding mountain roads. 5 hours for every patient needing urgent medical care. 5 hours for every student trying to reach a university. 5 hours repeated endlessly for anyone who simply wanted to leave. And once this airport opened, that same journey collapsed down to 45 minutes in the air. And that single number, 5 hours down to 45 minutes, is the entire reason this project existed in the first place. This region sits beside one of the most spectacular natural gorges anywhere on the planet, a place that draws roughly 6 million tourists every single year despite its isolation, yet officials estimated the punishing road access was actively blocking an additional 10 million visitors annually who simply could not justify the journey. So before a single explosive charge was ever planted, engineers spent months surveying every available ridge across the entire county, evaluating slope angles, rock composition, and available space, and out of every single option they examined, only one mountain, known locally as Taohua Mountain, actually had the geometry required to support a full-length commercial runway. Turning that decision into reality carried a price tag of $252 million, simply to remove a mountain from existence, an amount that sounds almost absurd until you understand there was genuinely no other way to create enough flat, stable ground in this landscape. And once the financial numbers were run and approved, there was no turning back. Engineers involved in the earliest planning stages later admitted that no comparable project existed anywhere in the region to draw guidance from, meaning much of the surveying methodology, the blast sequencing logic, and the fill compaction. Strategy had to be developed specifically for this single mountain, refined through trial and constant recalibration, as the true scale of the challenge slowly revealed itself layer by layer. From the outside, that mountain looked completely solid, dense, ancient rock that had sat undisturbed for 100 million years, but nobody yet knew what was actually hidden inside it, because buried throughout. Its interior were 40 separate natural caves, hollow voids inside solid-looking rock that would not reveal themselves until demolition was already underway. And one of the earliest caves discovered, a chamber 12 meters wide and 7 meters tall, sat directly beneath the exact line where the runway itself was planned to go. A discovery that instantly complicated an already extraordinarily difficult engineering problem, forcing crews to pause active blasting nearby while geologists physically entered the cavity to map its exact boundaries, because charging explosives anywhere near an unmapped void risked triggering an uncontrolled collapse that could have swallowed equipment, or worse, workers standing on the surface directly above it. In the first week of work, the mountain still stood completely untouched, exactly as it had for 100 million years. But within 7 weeks, the very first demolition blast fired into its surface, and on April 20th, 2015, one single button press triggered the explosion that would mark the true beginning of 4 uninterrupted years of demolition and construction. Before any large-scale blasting could even begin, engineers faced an immediate logistical problem because there was no road capable of carrying heavy machinery up to the summit, so before the mountain could be destroyed, workers first had to carve an entirely new access road directly into its slopes, just to get equipment to the top. Along the planned runway line, engineers identified 78 meters of solid mountain rock that needed to be removed entirely, and that boundary was marked with bright red paint across the rock face, a simple visual line, separating what would remain from what was about to disappear forever. To bring down that first major section, crews drilled 180 separate holes into the rock and packed each one with explosive charge, an enormous, coordinated demolition sequence aimed at a mountain that had no idea what was coming. When that charge finally detonated, 18,000 cubic meters of solid mountain rock came down in just 2 seconds, an almost unbelievable instant of destruction that officially marked the true start of the demolition campaign. And once that first blast succeeded, the pace of destruction became almost industrial, with crews removing roughly 45,000 cubic meters of rock from a single peak every single day, while 6 additional mountains still stood waiting their turn, each one eventually Subjected to the exact same relentless sequence of survey, drill, charge, and detonate, a repeating cycle that crews would come to know so intimately that the entire process eventually felt less like construction and more like a slow, deliberate erosion carried out at industrial speed. On the very first day of fill work, engineers had managed to place just 2 meters of crushed rock inside a valley that measured 45 meters deep, leaving 43 meters still to go, an almost demoralizing ratio that made clear just how much material this project would ultimately require. And site supervisors reportedly kept a running tally posted at the valley edge, specifically so crews could see, in real numbers, exactly how far the fill still had to climb before the valley floor would finally match the elevation the runway design required. Standing on what remained of the first peak during construction, an engineer noted that this exact rock, the very stone beneath his boots at that moment, would eventually sit directly underneath the finished runway 4 years later because nothing removed from these mountains was ever wasted. Every single blasted section of rock was crushed down and then deliberately rebuilt layer by layer to become the very foundation the runway itself would rest upon. Work never stopped, running in 3 continuous shifts across 24 hours a day, 365 days a year, and for 4 consecutive years, this mountain never once went dark. Floodlights and machinery running through every single night without pause. Every single layer of crushed fill material was compacted, tested, and formally approved before crews were permitted to add the next layer on top of it. An obsessive quality control process necessary because a single weak layer buried deep inside the fill could compromise the stability of everything built above it years later, and inspectors reportedly rejected entire sections of freshly placed fill on multiple occasions when compaction readings fell even slightly outside specification, forcing crews to excavate, reprocess, and replace. Material that had already taken days to place, an expensive and frustrating setback each time it happened, but one nobody on site was willing to skip. At one point during construction, engineers watched 40 centimeters of ground simply drop overnight, revealing yet another hidden cave that the original geological survey had completely missed, and crews responded by pumping 380 cubic meters of concrete directly into that single cave to seal it solid, even as 39 more undiscovered caves still waited somewhere beneath the surface. At the peak of construction activity, 3 separate mountains were being actively demolished simultaneously, and the visible ridgeline of the entire site changed noticeably from one week to the next, an almost unrecognizable transformation happening in real time. Beneath where the runway itself would eventually sit, engineers drove 340 separate concrete piles down 67 meters until they struck solid bedrock, an entirely invisible support system buried far beneath the visible surface of the finished airport, quietly doing the structural work that no visitor stepping off a plane here would ever think to look for, let alone appreciate, and installing each one involved, lowering a 7-ton steel reinforcement cage 67 meters straight down into the drilled shaft. A process repeated 339 additional times until every single pile matched exactly. An engineer working on the pile foundations later explained that 7 meters of solid rock beneath his feet was providing structural support that crushed and compacted fill material alone could never have achieved on its own. One particular cave discovered later in construction measured 18 meters wide and 8 meters high, buried 28 meters beneath the surface of the fill, making it by far the largest hidden void found anywhere on the entire site. And when engineers realized how large and how unstable that cavity actually was, work crews received an urgent order to evacuate the entire surrounding zone immediately while specialists assessed the risk. Stabilizing that particular cave required 72 continuous hours of grouting work carried out through the night, pumping stabilizing material deep into the void while monitoring instruments confirmed layer by layer that the process was actually working as intended, ultimately requiring 20 cubic meters of grouting material to fully seal it. Down in the valley below, residents watched their familiar skylines slowly disappear week after week, an entire mountain range vanishing gradually before their eyes over roughly 2 years and from a single peak. Alone, engineers eventually removed 2.8 million cubic meters of rock, a volume larger than the total concrete used to build the Hoover Dam, an almost impossible comparison for a single mountain torn down for a single runway. And engineers on site later remarked that watching the trucks haul away that volume of rock day after day, month after month, felt less like a construction project and more like watching an entire geological feature slowly erased in real time by human hands and machinery. The construction rhythm never changed. Drill, blast, and excavate, repeated across 365 days a year for 4 consecutive years, without a single day off, anywhere on the schedule. By the time crews reached what they designated Cave Number 40, the very last hidden void discovered anywhere on the mountain, engineers could confirm that every single one of those 40 caves had been located and completely filled solid. Not one had been missed. an extraordinary outcome given how many had been discovered completely by surprise throughout the project, and geologists later noted that the sheer density of hidden voids inside this particular mountain was unusual even by regional standards, meaning the survey and grouting protocols developed here would likely inform future mountain leveling projects attempted anywhere else in similarly karst-prone terrain across the country. In the Central Valley targeted for fill, week 1 showed nothing but bare valley floor, yet by week 20, that same 45-meter-deep valley had been completely filled to the top, an entire landscape feature erased and replaced with solid engineered ground. A transformation so complete that drone footage comparing the two states side by side barely resembled the same physical location at all. Eventually, only a single mountain remained standing, rising 71 meters above the planned runway surface, still intact, still blocking the final section of flat ground the project required. Though its time was clearly limited, and crews reportedly treated the demolition of this final peak with a strange mix of urgency and reluctance. Urgency because the entire project timeline hinged on finally clearing it, and reluctance because, for many of the workers who had spent years living beside these mountains, this last summit had quietly become the final visible marker of the landscape they had known before construction ever began. An engineer, standing amid the wreckage of 6 demolished peaks, with only that final mountain still visible, described the surreal experience of physically standing inside what used to be 7 separate mountains, now reduced to open space and a single remaining obstacle. That final peak was visible from as far as 15 kilometers away, before demolition crews began bringing it down, and the day that very last summit finally started falling marked the moment when, for the first time viewed from the air, the site actually began to resemble something recognizable as an airport rather than an active demolition zone. Just flat exposed rocks stretching across what had once been a mountain range, a sight that reportedly stopped even veteran crew members mid-task, several of whom later described it as the first moment the entire abstract engineering plan actually felt tangible and real. Even after the physical demolition work finished, engineers still needed to compress the fill further, deliberately piling additional temporary weight on top of the compacted material, specifically to squeeze it down and stabilize it before the actual runway surface could ever be poured on top. Across the entire 4.5-kilometer length of the engineered platform, surveyors measured a maximum deviation of just 28 millimeters, an extraordinarily precise result confirming the massive constructed platform was, for all practical purposes, perfectly flat despite sitting entirely on rebuilt mountain fill. To make sure that flatness held permanently, engineers buried 280 separate monitoring sensors directly beneath the runway surface, instruments designed to continuously track any movement in the ground below, forever, for as long as the airport remains in operation. Just as with the underlying fill, the runway's structural foundation followed the same core philosophy. Crushed mountain material broken completely down and then deliberately rebuilt layer by layer into the very foundation supporting the finished pavement above it, with crews placing roughly 400 meters of concrete base course every single day, as the physical runway itself slowly began to take shape. Engineers specified a custom concrete mixture specifically engineered to withstand 300 separate freeze-thaw cycles, necessary because of the extreme temperature swings common at this mountain altitude, and once that surface was finally complete, the runway existed as an actual usable structure for the first time. Tiny textured grooves cut precisely into the finished concrete surface exist for one specific safety purpose, helping aircraft brake and stop safely before ever reaching the cliff edge waiting at the far end of the runway. Standing on that freshly poured surface, an engineer noted that he was physically walking across ground that used to be 7 separate mountains, the concrete beneath his boots still new enough to feel almost fresh from construction. In temperatures as low as -8 degrees, crews poured sections of runway concrete under insulated protective blankets at midnight specifically to control the curing process in freezing conditions. And across the entire runway, workers hand-sealed 1,573 meters of expansion joints, because even a small amount of water infiltrating those joints could eventually cause the surrounding concrete to crack under repeated freeze-thaw stress, so no shortcuts were permitted anywhere along that sealing process. At the very end of the runway, engineers installed 90 meters of specialized crushable concrete material specifically designed to absorb the energy of an aircraft that overran the runway, acting as a final designed safety buffer, standing between a runway excursion and the open gorge beyond it. The very first time the runway's approach lighting system switched on, residents down in the valley reportedly stopped what they were doing simply to stare upward at lights glowing from a location that used to be solid mountain rock. Engineers were equally insistent about installing a full Instrument landing system, because without that guidance technology, an airport positioned this deep inside mountainous terrain and frequently obscured by cloud cover would only be usable roughly half the time, an outcome the project team considered completely unacceptable, given everything already invested to reach this point. So calibration flights and ground-based signal testing continued for weeks after the physical installation was finished, engineers repeatedly checking approach signals against the surrounding terrain until every reading matched precisely what the flight procedures required. The entire terminal and runway complex was engineered to withstand sustained winds up to 120 kilometers per hour, a necessary specification because virtually nothing along this exposed mountain ridge offers any natural shelter from weather moving through its gorge. Construction on the terminal building itself followed its own rapid timeline, with foundation pads completed within the first month of that phase and a fully recognizable terminal structure oriented specifically to face the surrounding mountains, standing complete by month 4, ultimately. Accommodating 5 aircraft parking stands squeezed into the smallest possible footprint the site's extreme geography would allow, because on a mountaintop, this constrained every single available meter of usable space carried enormous value. One architect involved in the design explained that passengers looking out through the terminal's windows would be able to see, immediately and viscerally, the true scale of what had been built here, a structure intentionally designed to feel physically connected to the dramatic, rugged landscape surrounding it, rather than isolated from it. The airport was ultimately named after a well-known local mountain goddess, a name carrying a certain irony given that the very mountain she was said to inhabit had been the one physically demolished to make room for the runway itself. Because of its remote mountain location, the airport receives its jet fuel supply by road tanker delivered roughly every 3 days, a logistical reality that quietly shapes daily operations at a facility this isolated. During its first winter storms, 5 centimeters of snowfall combined with temperatures dropping to -8 degrees tested the airport's operational readiness directly, and ground crews managed to clear the entire runway surface in just 38 minutes, well inside the 60-minute standard required for continued safe operation. The surrounding mountains also bring roughly 1,200 millimeters of rainfall every single year, meaning drainage engineering mattered every bit as much as the concrete work itself in keeping the runway safe and usable across every season. Despite the scale and complexity of everything built here, the finished airport is operated by a team of just 45 people, officially classified as the smallest 4th category airport staff in all of China. A designation the entire team reportedly understood came with serious operational responsibility given how much complex, safety-critical infrastructure they were now responsible for maintaining, monitoring everything from the buried sensor network to the drainage system to the instrument landing equipment with a level of attentiveness usually associated with airports, many times their staffing size. During final certification, testing, an aircraft attempting a rejected takeoff scenario managed to stop with exactly 700 meters of runway still remaining ahead of it, a margin that quite literally represented the difference between a successful test and disaster at the edge of the gorge. When the lead safety inspector finally walked out to physically stand at the very edge of that cliff, looking straight down into the gorge below before turning back toward the runway, he ultimately wrote a single word on his official report: pass, formally clearing the airport for passenger operations after 4 years of continuous work. On the evening before opening day, engineers on site knew that the following morning, actual passengers would land on a runway surface that, only 4 years earlier, had not existed in any form, replaced entirely by solid mountain rock. In those final hours, every single airport system was formally switched on, every required signature collected and filed, with just 1 week remaining before the very first scheduled passenger flights were due to arrive. For comparison, a modern aircraft carrier measures roughly 333 meters in length, while this completed mountaintop runway stretches 2,600 meters, nearly 8 times longer, an intentional design choice ensuring that even the largest commercial aircraft could operate here safely and comfortably. From certain angles, the finished runway surface appears perfectly flat to the naked eye, though in reality it is not, because the underlying mountain terrain ultimately forced engineers to accept one final unavoidable compromise in the overall grading of the surface. Hidden directly beneath sections of the finished runway sits an accessible inspection chamber a space engineers can physically enter periodically to visually confirm that the buried structural systems below the surface continue holding exactly as designed. On certain mornings, low clouds actually settle beneath the elevation of the runway itself rather than above it, meaning the airport's popular nickname as a cloud airport is not simply a marketing phrase, it is a literal, frequently observed meteorological reality at this specific mountain elevation. Across the entire 4-year project, workers and machinery ultimately moved a combined total of 40 million cubic meters of material, a volume roughly equivalent to 15 Great Pyramids of Giza, accomplished using 800 pieces of heavy machinery working continuously across 4 uninterrupted years until the project finally reached completion. Once painted markings were finally applied to runway 24, directly at the edge of the surrounding cliff, the airport stood physically complete for the very first time, a genuine engineering endpoint reached after everything that came before it. An engineer who had walked this same ground back when it was still solid, unbroken mountain rock, later reflected on standing at that same location once construction had fully finished, struck by just how completely the landscape had been transformed. During a formal flight test, conducted before opening, a pilot executing a deliberately simulated missed approach had to immediately begin a climbing turn because on a go-around at this specific location, mountainous terrain sits directly ahead of the runway threshold. A stark reminder of exactly how tightly this airport is boxed in by the very landscape it was carved out of. In the days leading up to opening, the terminal building sat completely empty except for a single upcoming flight listed on the departures board. A quiet, almost eerie calm before the airport's very first real passengers were due to arrive. Every single pilot approaching this airport can see 12 distinct surrounding peaks lining the final approach path, and the airport itself carries the name of just one of them, a small but symbolic detail connecting the finished facility permanently to the landscape that had to be destroyed to create it. A quiet reminder repeated on every single flight in and out of exactly what stood on this ridge before the runway ever existed, and of everything it took, mountain by mountain, cave by cave, year by year, to bring it down. Underneath the feet of every passenger walking across that finished runway sits an entire invisible support system working. Continuously and silently, 340 structural piles reaching down to bedrock, 280 embedded monitoring sensors, and 40 separately discovered and fully grouted underground caves. An entire hidden engineering network functioning exactly as designed without any visitor ever seeing so much as a trace of it. 4 years of buried, invisible work quietly, holding up every takeoff and every landing that happens here from now on. Proof that the most important parts of this airport are the parts nobody standing in the terminal will ever actually see. One elderly local resident reportedly watched the mountain outside her home gradually disappear over the course of several years of continuous demolition work, and on opening day, she was finally able to board a flight departing from the very same location where that mountain used to stand. Workers who had personally spent years demolishing the mountain were reported to have cried openly at the airport's official opening ceremony, an emotional reaction that speaks volumes about exactly how much sustained human effort this project genuinely demanded from everyone involved. Monitoring data collected from all 280 embedded sensors confirmed that every prediction engineers had made about ground movement and settlement across 4 full years of construction had proven accurate, with the collected data ultimately displayed together as a single consolidated verification graph. Even after the main runway officially opened to passenger traffic, drilling crews returned to the site to extend the facility by an additional 400 meters, applying the exact same demolition and construction methods used throughout the original project to that same mountain. During that extension phase, engineers discovered 3 additional hidden caves inside the expansion zone, and true to the pattern established throughout the entire original project, each one was located, grouted solid, and construction simply continued without significant delay. After 4 years, 7 demolished mountains and roughly 2,000 workers involved across the full duration of construction, the airport finally opened its doors to passengers for the very first time. The very first pilot to land there reportedly walked through the still largely empty terminal building, paused to look out at the surrounding gorge, and then simply left. A strangely quiet, almost anticlimactic ending to one of the most extraordinary engineering projects ever attempted inside a mountain landscape. And yet, for everyone who had spent 4 years drilling, blasting, grouting, and pouring concrete across that ridge, the silence of that moment carried its own weight, a private acknowledgement that the impossible task they had been assigned years earlier had, against every early doubt, actually been completed exactly as designed, because in the end, engineers had quite literally deleted 7 entire mountains from the map in order to build a functioning runway suspended in the sky above one of the deepest gorges on Earth. And if projects this audacious and this extreme genuinely fascinate you, subscribe now, because there are even more impossible megaprojects waiting to be broken down next.